Okay, I think it's time. Good morning and good evening, or good afternoon. This is Chieri Kubota. I'm a professor at the Ohio State University. Welcome to Indoor Ag Science Café, August. So we had a good, summer break. So we didn't have any indoor cafe July. We are starting again this new academic season. I'm so glad USDA is funding this effort, and then also all the team members who are co-organizing this effort. So again, this is a project funded by USDA. Institutions participating in this project is led by Michigan State University, and then co-investigators are located in Ohio State University, Purdue University, University of Arizona. So let's start this month's cafe. Welcome everyone participating. First of all, I'd like to go over the upcoming cafe series. Today is a special, so that's why we started 1 hour earlier than usual because of the time difference between US and Japan. And then September, we will have another international speaker from Delphi, Netherlands, talking about fruit production in indoor vertical farming. And then we have a technology showcase series number 3. 3 companies sign up for that. So look forward to that. And then November, we will have another fruit production talk. This is actually the more for a pharmaceutical application originally, but this group at Chiba University, Shoko Hikosaka, doing a lot of work, the growing plants in the optimized conditions. So I think it's good to have her to speak. And then she's in Guelph, University of Guelph, as a visiting scholar. So that's gonna be something you might look forward to that. All right, and then upcoming event schedule you can find in this OptimIA website. OptimIA is the acronym of our project, so you can check it out to find something interesting. All right, so today's agenda, hydroponic production systems and methods in Japan. So the presenters and then also those who contributed to presentations are from Mitsubishi Chemical Aqua Solutions. I tend to pronounce MCAS, but I'm not sure. MCAS is the acronym, Mitsubishi Chemical Aqua Solutions. And then original presenter or the contributor was Akio Nakaminami. Akio Nakaminami. Nakaminami-san had an unexpected death in his family, so he couldn't participate today. So we have Aizawa-san, Koichi Aizawa, who is the general manager of the plant factory division at Mitsubishi Chemical Aqua Solutions. Aizawa-san, would you like to say something, to say hi?
今日は、植物工場営業担当してます。相沢と申します。よろしくお願いします。植物工場営業歴29年になりまして、いろいろと植物工場の知識はあると思いますので、よろしくお願いします。
So he has been in that division of plant factory 29 years, and then knowledgeable about plant factory design and system operation. And today is a spinach production related, but I'm sure he can answer many different questions. So look forward to that. ありがとうございます、相沢さん。
はい。
Okay, so, and then because of the language issue, we decided to have me as a information delivery person. So I'm going to go over the presentation using their slides. So I tried to do my best, probably 30 minutes, 35 minutes to deliver. We have a video at the end. So that's the plan. Okay, let's start the presentation. So again, the slides are prepared mainly by Nakaminami-san, who is also in the plant factory business division, hydroponic spinach production systems and methods in Japan. So a little bit about Mitsubishi Chemical Aqua Solutions, MCAS. It's located in Tokyo. And then this is a company or one of the companies under Mitsubishi Chemical Corporation. So the Mitsubishi is a large group company corporation. And then this company, MCAS, is under the Mitsubishi Chemical Corporation. And then their main business is water-related, water treatment. So the purification of water or ultra purification of water or wastewater management, and then the films and resins and, all that water treatment related business. So their main customers, if I understand, are like a medical sectors or semiconductor, manufacturing operations. But uniquely, they have agriculture sector and then focusing in controlled environment agriculture, specifically plant factory, which they, in their definition, I think covering high-tech greenhouse and indoor vertical farms. So that's the company profile. So in that, agriculture sector, the unique concept they have is combination of indoor technologies, indoor vertical farm technologies, and then also greenhouse. So they have developed, let me change to pointer. Okay. They have developed indoor plant production system. They call Naya Terrace or Naya Terrace. That's sort of the beginning of vertical farm, actually. Original concept is actually developed in Chiba University when I was in Chiba, led by Toyoki Kozai. We focused on indoor transplant production system, closed transplant production system. And then company Taiyo Kogyo, which is a former company who started this effort, developed this commercial or commercialized version of indoor transplant production system. But anyway, the concept is starting plants in a fully controlled environment, and then producing high quality, very strong seedlings. And then those seedlings or transplants are transplanted in a growing system. And then in spinach case, greenhouse. And then they have also a specialized hydroponic NFT-based system. Their product name is Napaland. So we're going to talk about mainly those, two systems, combination of indoor transplant production and then greenhouse hydroponic leafy green production. They have now new system. They just released, I believe this year, AN, which is Agriculture Next, abbreviation of Agriculture Next. And then that's basically indoor vertical farm, but very unique. I probably show you a picture or two during this presentation. Oh, that's right. Yeah. Okay. So yes. So they started this business 30 years or so. So they have many users of those technologies. So just showing the summary of the users. Naya Terrace, which is the indoor transplant production system using electric lighting, right? So the vertical farm specialized for transplant production. 190 operations in small country Japan, they have as users. And then some of the operations actually have more than 10 units operating to produce high quality seedlings. Not necessarily just, not necessarily for leafy green only. They also produce like a tomato plants for grafting and things like that. So the high-end transplant production. Napaland is 130 operations. So that's an NFT production system originally designed for spinach, but expanding the product portfolio so that beyond spinach, 130 operations. And they have also now China, they can sell China and 34 operations. Total acreage of 34 operations in China is 12 hectare, which is translated as 30 acres in US or British unit. And then they have now one operation of the vertical farm, totally, controlled environment, vertical farm. All right, so let's look at the individual systems. Naya Terrace, closed transplant production system with electric lighting. So again, the concept was developed by Toyoki Kozai and then collaboration basically led into commercial product development back in 90s. So you see that multi-layer production system, multi-tiered production system, controlling temperature, light, CO2, in some cases humidity, and then irrigation, sub-irrigation system. So the concept is, without too much experience, using this system, anyone can grow high-quality seedlings. And then the picture on your right is actually a tomato seedling picture, very uniform tomato seedlings used for grafting. So grafting is another high-end technology for fruiting vegetables. And then this system is very much suitable, I would say, for uniform grafting materials production. Okay, so next. So this slide is showing the benefit of using artificial electric lighting or controlled environment, completely controlled environment for seedling production. The slide has two crops example. One is brassica, rapa, Mizuna. The other one is butterhead lettuce. And in both cases, the slide is showing the impact of seedling growing environment in the greenhouse finishing, products. So here, oh, by the way, Mizuna, I don't know if you are familiar with Mizuna. Brassica rapa, it's very crispy, good leafy greens for salad. I think in North America, you probably grow Mizuna as a part of baby leaf mix, never be standalone produce, but it's very popular in Japan and actually my favorite leafy green. Grown to the full head and then chop up and then the great salad. You don't need lettuce. It's just you can enjoy Mizuna. But anyway, so that's the crop. And then you can see two different environments tested for comparison. One is Naya Terrace, which is the electric lighting vertical stacking system. The other one is a standard greenhouse, on the bench under sunlight. You can see the slight difference maybe in this slide, but if you look closely, this Naya Terrace grown plants have already advanced growth stage so that you can see the true leaf sticking out in addition to cotyledons. It is very typical to put multiple seeds in one plug, so that's why you see so many cotyledons. And then sunlight grown one is a little bit more stretched. And then you can't tell by picture, but it's relatively weak under sunlight. Naya Terrace grown one is a more compact. That difference you can see very well in lettuce because lettuce respond to the light quality and all the environment relatively more vigorously. So that's why Naya Terrace grown one is much more compact, and then sunlight grown plants are more expanded. If you use those seedlings, the final product morphology and quality are also different. So in Mizuna case, this is very typical sunlight grown Mizuna and kind of U-shaped crown, right? And then these are actually, it looks like stem, but actually petiole because it's a crown, like a rosette type of structure. So if you harvest those, it's very tough because it's so easy to break and takes long time to harvest if you do not want to break any petiole. Versus Naya Terrace grown seedlings generate this full head, so that the quality during the seedling production would improve the quality of the final product. Those are both in the same greenhouse, same Napa land hydroponic and NFT system grown. So you can see that more like a very strong V shape, easy to harvest, and then also good quality. For lettuce case, you see visually more compact full head when the seedling started in Naya Terrace, and then a sunlight throughout seedling stage and then also production stage. It's kind of loose head. And then Naya Terrace, when Naya Terrace was used for seedling production, it's more uniform leaf development. So that's the slide showing the impact of seedling production conditions. All right, so let's talk about spinach and then system, NFT system. So when I first look at this picture, I thought this is a DWC or shadow, water culture system. And then it was wrong. It was NFT. It's a wide bed. Main material is styrofoam. So the upper part is styrofoam. And then also the bench is also molded styrofoam. So the high density styrofoam. So it is an NFT, so the nutrient film, constantly recirculating in this system. So this is the drainage, right? And then that goes to the tank, the reservoir, and then circulate what in that is the other side of this long bench. Very uniform, you can see, and very clean. The surface of styrofoam doesn't have any algae growing over the surface. If you're familiar with DWC using styrofoam, you have this issue, right? Sort of, getting algae and then green and then a dead algae brown, and then it's not really looking good. But this is clean because there's a certain, thought in the design, really good design. But anyway, so this is I think it's cilantro. Yeah, cilantro grown in this system. And then this is a picture of spinach using same system. And then this is a lightweight benches. Therefore, you can easily move around. So this is a movable NFT system, so that you can maximize the floor use efficiency or the space use efficiency. All right, the next slide. So this is a cross section of the NFT system of the Napa land, which is the product name. So the project of development of this type of system started in 1990s. And then commercialization or putting into the market for sales started back in 1995. So they have been doing this 30 years nearly, right? 30 years. The original goal of this designing, NFT system or hydroponic system specific to spinach was because spinach is very challenging crop to grow. And then also it's very much affected by heat during summer. So year-round production is the goal. Because of this system, they can now, or their customers can now 18 production cycles per year. And then that's why so many users in Japan. All right, let's take a look at closely at the close section. So the upper part is styrofoam, lower part is styrofoam. So it's just insulating, right? Why? Because they want to do a temperature control of the nutrient solution. And then insulation is the best way to, reduce the cost of temperature control. And then another important thing is the surface of the bed or the bench is up and down and up and down. So a little bit higher elevated, I don't know, 1 centimeter or 2 centimeter, maybe 1 centimeter or so, elevated part is the place where plugs are sitting. So the seedling plugs are sitting on the elevated part. And then lower part is like, water stream channels. So that's NFT, very thin, 1 centimeter or less, probably, continuously circulating. So by sandwiching that space with panels, right, what you can create is very humid airspace, nearly saturated. And then that near saturation would allow the plugs or the roots come out more fine root system, root hairs, a lot of root hairs. So you can see that in this picture. So the aerial roots, and that would enjoy oxygen access. And then more like a tap roots coming out to the nutrient solution stream, and then absorb water and nutrient very efficiently. And then there is some kind of fabric underneath, and then that is sort of, I think it's a wick type of effect, so that not completely dry out the plug, but it's not gonna wet or saturate the plug. if I said before, but I like to repeat, spinach is very sensitive to oxygen, or they like oxygen access. Oxygen requirement is very high for spinach, and that's why they designed this way. Okay, I think I covered everything in this slide. All right. So, oh, one more. Yeah. So the reason I said that surface is clean, styrofoam, is because styrofoam is not touching nutrient solution. That's why. So I thought it's a great idea. All right. So this slide is a little bit busy. However, let me go over. So design concept number 2, which is also key concept, is a batch production, batch to batch. Instead of our more conventional way, sort of continuous usage of the same system. You may not like the idea, right? Because the space use efficiency may be not that great, batch by batch or batch to batch system. But there are a lot of advantages because it's a batch system. So first of all, you can isolate the crop, right? So if you have a problem, you can start over again without affecting the rest of the crop. So that's one thing. Another thing is start over again would give you opportunity to thoroughly clean. So they could even do sterilization every single batch. How? They use 60 degrees C hot water, circulating entire batch system, I believe 1 hour or so. And then that would basically pasteurize and then, take care of most of the pathogens. So that's great. So this is actually the sort of top view. You see the multiple benches, NFT benches, and then each set of benches, there is one small sub-tank. So that's a secondary reservoir, and then the circulation is happening with the sub-tank. Main tank is serving nutrient solutions to the sub-tank. And then that's the basically mixing, fertilizers, right? And then adjusting EC. Sub-tank volume is amazingly small. I was shocked when I was asking questions, how much volume? And then it's like a 400 liter or 100 gallon to serve 9,000 plugs with multiple plants in it. So if I compute, it's teeny tiny compared to what we usually consider as a design of NFT system or DWC. DWC is way more, right? The nutrient volume. That's why you don't want to dump the solution. You want to save. That's why you want to continuously do that. But if the reservoir size is such small, the impact to the environment is minimum. And then in addition to that, because the volume is small, temperature control is easier, right? Because water has a huge heat capacity. So temperature control doesn't require that much water. And then the insulation, right? The growing system. Another good thing, toward the end of production, they stop feeding nutrient solution to the sub-tank. Okay? What happened, because plants take up nutrient continuously, but such a small volume, nutrient concentrations decline rapidly. So toward the end of production, when they harvest the crop, most of the key nutrients are very low concentration. So that is another way to reduce the wasteful use of nutrient. And then also another additional benefit, not so much in US, because we don't consider as critical issue, but Asian countries, European countries are more, paying attention to the nitrate concentration in leafy greens. And then by reducing fertilizer solution concentration toward the end of the production, several days before harvest, they can reduce the nitrate concentration of the leafy green. So this is the chart showing the declining nutrient concentration. This is the nitrate. The blue line is nitrate nitrogen. And then this darker blue line is the leaf nitrate concentration. So the declining about half level compared to the maximum. So that's another advantage of this approach. And then this is a picture showing a small sub-tank or secondary reservoir attached to the batch of benches. All right, so let's look at the steps of spinach production. So if you grow spinach, you know germination is really hard. And then this is how they overcome the issue. So selecting substrate and then also selecting seed technology. So this is a comparison between very commonly used urethane form for leafy green hydroponics. It's very common in Japan and then probably in other Asian countries too. Low cost and then good material. However, if you use urethane for spinach, they just don't germinate. Again, they don't like the saturated, moisture environment because it suffocates and then oxygen accessibility is reduced. So they need to do much better substrate use or selection of substrate. And what they selected is a granulated rock wool. It can be a horticultural mix, but what they prefer is or recommend is a granulated rock wool. And then rock wool, as you know, it's saturated, right? Hold a lot of water. So you can't do that for spinach. So what they do is precise moisture control. Rock wool has a lot of airspace. So instead of filling that airspace with water, you want to limit the water amount precisely so that air is available in the root zone. If you do that, you get very nice, seedling establishment. And in addition to that, seed technology contributes to increase the germination rate even higher, and then also stand establishment greater. If you are familiar with spinach seedlings, it's sort of the true seeds are inside of pericarp. It's a dry shell. And then that shell or pericarp absorb moisture and then suffocate the true seeds. So they have a technology to remove that shell or dehalling technology. Maybe I may be wrong in the terminology, but basically removing the pericarp, and then they call naked seeds. And then that is recommended seeds because that can germinate even faster and then more uniform. All right, so this chart or the slide show two charts, graphs showing the effect of moisture content in the plug or the substrate. And then also effect of difference of seeds, whether it is untreated or the non-naked seeds, and the other one is naked seeds. So the seeds covered with pericarp. If you look at the chart, so the x-axis is water content per cell. So this is 1 milliliter per cell over up to 6.5 milliliter per cell. And then 6.5 milliliter per cell is almost saturated, situation. And then in that case, if you use non-naked seeds, germination rate after 9 days is the blue bar. After 9 days, it's not even 50%. That's exactly what we know, what we experience in spinach production in moist substrate. You have to reduce the substrate to improve the germination rate. So the bar starting with 3, 4, 5, 6, 7, 8, 9. So if you reduce the moisture content to 1.0 milliliter, then you can get 90% germination rate after 8 days, green bar. So, but if you use naked seeds, wide range of moisture they can germinate, 1 to 5. And then optimum seems to be 3 milliliter per cell. And then after 5 days or so, already reaching 90%. So it's obvious moisture content, precision moisture content, together with usage of great technology of the seed actually make the difference. Okay. Now, that difference in the germination or seed technology difference that would affect the germination rate, maintain during the seedling production. That's why it is always best to use the good technology for spinach. All right, and then according to this information, 7 to 8 days in the Naya Terrace indoor production system, and then transplant it to the hydroponic system in the greenhouse. Counting from the seeding day, it's 10 to 11 days. So that's spinach, typical what they see. All right, so this is a transplanting stage. Look at the uniform spinach and very strong seedlings of spinach, and then spinach pulled up, so easy to transplant. Most of the, I think, growers are doing manual transplanting, but it could be automated if you want to. The holes of the NFT panels or NFT system panels are slightly larger than the plug size, so it's easy to drop the seedlings into the holes. And then again, underneath of the seedling, it's a little bit elevated platform so that the plugs are moist but not saturated. So that's the design of the NFT. And then this is a picture at the time of harvesting. And then you see the nice root development. And you see that, up and down elevated area, and then also the channel of the nutrient solution. They usually cut the roots first at the bottom so that easy to pull out and then pack them. And then 15 days after transplanting in summertime, 28 days winter time. Japanese market usually appreciate the big head of spinach rather than baby green. So if you are applying this to baby green, I think you need to have an adjustment of density and stuff like that. But anyway, so that's what they do. The last slide I have before I show video is the indoor vertical farm system they recently introduced in the market. And then one company either started, maybe somebody can clarify, but either started or under construction right now. Unique thing I want to point out, they use greenhouse. They use greenhouse structure and then put the insulation materials and the HVAC system and then convert that system into indoor vertical farm. And then design doesn't allow people to walk in. So it's greenhouse, but sort of, different. I'm sure it has some sort of, the logistic system inside. I don't know exactly. And then I'm looking forward to this, learning more about the system when they are ready. They just introduced in Japanese market. So I have to point out 300 grams of lettuce head they could grow in this system. So stay tuned. We invite them again to talk about this system. So now I would like to bring my video player here. I hope you can still see that. Okay. And then play this. Yeah, okay. Originally, this one is Japanese, and then Mitsubishi Chemical Aqua Solutions company people just added some translation. But I like you to just focus, the some English information, and then the image of the company who is using, or who is using both systems, indoor plant production system, and then NFT. But anyway, so let's watch that. I think you are hearing sound okay, but if not, please let me know. So this is a recap, the stages of seedling production. And this is after transplanting, all the way to harvest. says 19 cycles actually, not 18, 19 cycles. Crop cycles. So the combination of two systems, indoor plus greenhouse.
山梨県北杜市にある日通ファームの植物工場。
So this is, just wanted to stop briefly. So this is a company, it's about 1.2 hectare or so. So the 3 acres of the leafy green production. They don't grow lettuce. They grow spinach. They grow cilantro and some other high quality, high end leafy greens. The company is under Nitsu, so the logistic company. So it's very unique. And then the owner, or not owner, the president of this company is actually, no background of agriculture, no experience as grower, but she could do excellent job, operating this facility. But anyway, let's take a look.
ここに三菱ケミカルアクアソリューションズのある画期的なシステムが導入されているということで取材に訪れた。
こちらは日通ファームさんという水耕栽培の農場に
This is
なりまして、
actually Aizawa
弊
さん
社のナイテラスと
who
ナ
is
ッパー
with
ランド
us.
というシステムを導入していただきまして、一年中ほうれん草などの野菜を作っております。
日本通運といえば日本を代表する物流企業だが、異業種でも一年中旬な野菜の栽培を可能にするそのシステムとはどういうものなのか。
ナッパーランドナイテラスのきっかけとしましては、一年中ほうれん草を作るということをコンセプトにして作られました。ナイテラスというのは、苗繁作と言われてますけども、それを誰でも簡単に苗ができるシステムになります。
この苗テラスは人工光閉鎖型苗生産システムと呼ばれる最新技術を応用した苗生産装置。温度管理、光照射など全てを自動で行うので、季節や天候に左右されることなく、いつでも誰でも簡単に丈夫で均質な苗を作ることができる。
苗テラスで約8から10日間、その後定食しまして、約夏だと15日、冬だと30日くらいでですね、収穫できるサイズになります。
それを可能にしているのが、自然環境に左右されず肥料を含んだ水で育てる溶液栽培システムナッパーランドなのである。このように1年を通して旬な野菜を作り続けているのだが、その野菜の特徴とは。 この工場の責任者の方に聞いてみた。
サラダのために生まれた野菜をコンセプトに葉物野菜を作っています。農薬を使わずに安心安全な野菜を作っていまして、水耕栽培ですのでアクやえぐみが少なくて全部生で食べられるお野菜です。ビニールハウスの中ですので天候に左右されずに作業ができますし、全部腰の高さでできるので体への負担も少ないです。日本の農業は高齢化が進んでいるんですけれども、こちらの農場は私みたいな初心者であるとか高齢者の方、障害者の方でも安心して作業ができる職場になっています。
このシステムは食卓だけでなく日本の農業の未来も支えている。
Okay, so that's all I have, and thank you so much listening.